In this video, we're going to be creating equations, and each equation that we create, it's going to be based on a little description that we're given. So let's start with our first example. A taxi service charges a fee of 75 cents per kilometer driven. Create an equation for the cost C based on the kilometers driven. So we're going to create an equation that represents the cost of the taxi service. And we know from the problem that the cost is represented by C. So our equation is going to start off with C equals, because it's going to represent the total cost of a taxi ride, no matter how many kilometers that are driven. And we know from the problem that the taxi service charges a fee of 75 cents per kilometer driven. So let's make a little T table to represent what this actually means. On the left, we're going to have kilometers, number of kilometers, and on the right, we're going to have the cost in dollars. So if you're not driven at all, if you're driven 0 kilometers, our cost is going to be $0. If we're driven 1 kilometer, our cost is 75 cents. If we're driven 2 kilometers, well, we're just going to add 75 cents there. Our total cost is $1.50. If we're driven 3 kilometers, let's add another 75 cents. And this time the cost is $2.25. So every time we add 1 kilometer, our cost goes up 75 cents because we know we're being charged 75 cents per kilometer driven. And this should hopefully sound familiar to you. This number represents our rate of change. In the past, we've found the rate of change from a table of values or from a graph, but this time it's just given to us in the question, and you need to be able to recognize what it is. So remember, rate of change is always a number per something else, and in this case, it's our cost per kilometer driven, our cost per 1 kilometer. Now, what if I want to find out how much it costs for 10 kilometers? Well, we could continue our table and make sure we've added 0.75 10 times, or instead of adding 0.75 10 times, we can just multiply 0.75 times 10. And when we do that, we get 7.5. So for 10 kilometers, it's actually going to cost $7.50. And this doesn't just work for 10. If it was 25 kilometers, we would multiply by 0.75, or if it was 100 kilometers, we would multiply by 0.75, because we know that the taxi service charges a fee of 75 cents for every kilometer that's driven. So our cost is equal to 0.75 multiplied by the number of kilometers driven. So our equation that represents this situation is C equals 0.75K. So the cost of the taxi ride is equal to 0.75 times the number of kilometers driven. And remember, if you have a number right in front of your variable, that automatically means multiplication. So you don't need to put a multiplication sign here, and you don't have to put brackets. And now I want you to pause the video and try this your turn question on your own. And when you're ready, come back to the video to check your answer. And here is our answer. C equals 1.50K, or cost is equal to $1.50 times each kilometer driven. So this taxi service charges a fee of $1.50 per kilometer. This $1.50 is our rate of change. So for every kilometer that's driven, our price goes up by $1.50, which is why in our equation we can multiply every single kilometer by 1.50. Here's our next example. A taxi service charges a flat rate of $10 plus 75 cents for every kilometer driven. Create an equation for the cost based on the kilometers driven. So let's just make a T table to really understand what this means. On the left, we have our kilometers, and on the right, we have our cost in dollars. So for 0 kilometers, this time we're not charged $0. In our problem, it says a taxi service charges a flat rate of $10. So that means for 0 kilometers, we're charged $10. If there's a flat rate, it means you're always going to be charged that amount no matter what, and you're only paying that amount once. And sometimes it's known as your starting cost or your initial cost. And we're also being charged 75 cents for every kilometer driven. So this 75 cents is a rate of change. It costs 75 cents per kilometer. So for 1 kilometer, we need to add 75 cents. So our cost is $10.75. For 2 kilometers, we're adding another 75 cents. So our total comes to $11.50. And for 3 kilometers, we're adding another 75 cents. So our total comes out to $12.25. And similar to our previous problem, since our rate of change is 75 cents, we can multiply our number of kilometers by 0.75. So we're creating an equation to represent the cost. So our cost C is equal to something, and part of that cost is always going to be this starting cost, this flat rate of $10. So we're always including $10 plus our rate of change. And our rate of change is 75 cents for every kilometer that's driven. And since K represents the number of kilometers, we're multiplying 0.75 by K. So our equation is C equals 10 plus 0.75 times K. Our cost is equal to $10 plus 75 cents multiplied by the number of kilometers. So something to note in your equation, if you have a starting cost or it's a flat rate or an initial cost, whatever your problem might call it, if you have that flat rate, it's going to be on its own in the equation. And that's because you're only being charged that amount once. You're not being charged that flat rate over and over again. But your rate of change, this is something that's going to be multiplied by something else. Because your rate of change is going to be a cost per one item or 1 kilometer. So depending on the number of kilometers you have or the number of items that you're buying, your rate of change always needs to be multiplied by something. And now it's your turn to try this question on your own. So I want you to pause the video and create an equation that represents this scenario. And then you can come back when you're ready to check your answer. So here's our equation. C equals 8 plus 1.50K. So we have this flat rate of $8. This is the starting cost. So no matter what, for 0 kilometers, you're always going to be charged $8 plus $1.50 for every kilometer that you're driven. And this $1.50 is a rate of change. And I want you to read through these practice problems and try them on your own. There are a couple. Make sure you check your answers. They're right over here. And when you get to part B where it has these graphs, you can tune into the next video.